I'm Hunter Stevenson.
And I'm Anthony Fossilizza.
And today you're watching the Linux Anatomy of Actuation video series. So we're returning to you again with integrated controller on our actuators. We also call this IC, Burr. And we're going to be talking a little bit about some of the benefits of choosing an IC actuator over a standard DC actuator that you might normally run. So let's talk about how do we control a standard DC actuator normally?
So most often people just use toggle switches to change the direction of the actuator, like a double pull, double throw, polarity reversing. So often, this works just fine on kind of a smaller actuator with low current needs. But when we get to the LA36, sometimes you can use up to, like say on a 12 volt, it can go all the way up to 20 amps. And then if you're trying to find a toggle switch that can switch that type of power, it can be sometimes really hard to find, or also quite expensive.
Yeah. Another option to control a DC actuator is just using relays, but you end up having to put them in a control box, and those can be pretty expensive for that kind of current as well. Linac knew there was a problem with this, so they developed the integrated controller, or the IC that we talked about earlier. This developed a plethora of new cost-saving solutions that simplify the way you control a system, right?
Probably the most important part would be the low power switching, which you can just use a simple toggle switch in the milliamp range, or you can just use a signal from your control system.
Yeah, and all that low power switching originated at the H-bridge. The H-bridge is internal to the controller, and it even allows for that polarity reversing, but it also allows for you to self-lock the actuator when no signal is being sent to it. Self-locking is basically the actuator's resistance to force when it's not being moved at all. Linac decided to also add in feedback options to the Linac IC platform. So you can choose between current feedback, voltage feedback, all analog. You can do single Hall, and you can do PWM as well within the BusLink software.
But it's more than just feedback. We also offer configurable current limits for the stroke outwards and stroke inwards, as well as what we call a virtual limit. You can go in and set a specific stroke length that you don't want your actuator to overrun.
That's right, so that you can pretty much get any sort of configuration of actuator that you want out of any IC Advanced actuator. So speaking of IC Advanced, there's 3 different types of IC that Linac manufactures.
The first one being IC Basic, which incorporates the H-bridge motor controller, and it has in-stop signals. It's the most cost-effective version. Then we have the IC Advanced, which has our fully configurable feedback in our BusLink software, as well as in-stop signals and speed controls, everything.
That's right.
And then we have IC Parallel, which uses our motor controller, and it has its own bus communication. It can communicate up to 8 different actuators, so they can all run simultaneously.
That's right. So the nice thing about this is you don't need an external control box at all for IC Parallel. All the wires run between the actuators only, and it helps for a clean look.
And another nice thing about our IC system is that dimensionally and externally they're identical to our regular actuators, so you don't have to change anything about your install.
Yeah, that's right. So guys, thank you so much for joining us with the Linux Anatomy of Actuation video series. We appreciate you watching, and stay tuned for more videos in the future.
Thanks for watching.